So this is the first application in Virtual Lab 5. So the next one is going to use a lot of the same components, but we're going to make some variations. So we're going to do another save as, and this one I'm going to call sequential process 2. Now what we're going to do is we're going to change the valves, and they're going to be now spring return pneumatic valves. So I'm going to call this spring return valves. We're also going to add a rotary actuator in place of the cylinder B. And so that's going to involve some different programming. Okay, so the first thing I'm going to do is make these 3 valves spring return. So they're only going to have one solenoid, and the solenoid has to remain on in order for the valve to be actuated. Once it's released, it springs back. So if you remember from some of the earlier labs, I'm going to double click the component, go to technical specifications, and we can change the type of actuator on either side of the valve. So I'm going to change the one on the right. If I double click, it comes up with all the different options. And so I'm going to choose spring return and just check that off. And I'll do the same thing on the other 2 valves. The other change I'm going to make is I'm going to take out cylinder B, and I'm going to replace it with a rotary actuator. So I need to go up to the pneumatic menu, down into actuators, and if I just click on the top level actuator, one of them is a rotary actuator. So I'm going to drag this in, and I can move the flow restrictors in. Just going to line this up here. Now, one of the things about the rotary actuator is it doesn't have the option of using sensors. There's no built-in virtual magnet that you can use with the sensors. So I'm going to take out these 2 magnetic sensors. So now I no longer need the A- solenoid. There is no A- solenoid. So I'm going to take that out, and the B- and the C- are no longer needed. So I'm just going to tighten up the diagram a little bit. And then on the input side, I no longer need, well, the B plus and minus sensors are no longer there. So I'm just going to remove those. And I guess I'll move the C sensors over. So these sensors, I have to actually move them out, and if I just drag them over, it keeps this connected line. So I have to delete that connection before it'll let me move these over. Okay, now that I've made the hardware changes, I have to go into the PLC configurator and make the corresponding changes there as well. So under ladder, PLC configurator, and I no longer have these B0 and B1 inputs. I'm going to just change B0 and B1 to C0 and C1, but I have to delete C0 and C1 first because I don't think it will let me So to delete, you just click on the line, and up here it says delete input output. So I'm going to get rid of those and change this to C0, C1. And we also no longer need the minus actuators, so A minus, B minus, and C minus. We can delete those. So the C0 and C1 addresses or aliases that I just changed from B0 to B1, I'm getting a flag. It's giving me an error, and it's saying the alias of a register must be unique in a project. The reason that's showing up is that the original C0, C1 that were mapped to a different address are still being used in the ladder diagram. Also, the outputs that I deleted are also still being referenced in the ladder diagram. So we have to get rid of all those references. I'm just going to delete the whole ladder diagram except for the top rung. We're going to make a different ladder program, so we're just going to start over. The other thing we have to do is to go into the register tab and delete the original C0 and C1 from here. So there's a little delete register, and then get rid of the C1. And we also have to delete A minus and B minus and C minus. Now it looks like it kept the B1 name, so let's go back to input output. Yeah, it reverted back. So now I can change it. If I go C0, C1. Okay, so we should be all set with the changes. So now let's move on to the ladder diagram. A couple of things that are going to be different is that now for the actuator to stay in position, the solenoid has to remain powered on. So there's no A retract. Now it's just going to be either A plus is going to be on, and if it turns off, it'll spring back. So because of that, when I trigger A to extend, I need to latch it on. So this here is a regular output. It's only true momentarily when the start button is pressed. And so I have to change that to an output latch. So I'm going to delete this, replace it with a latch, and I'll just pick the A plus address off the list, which is right here. Okay, and just like before, we're going to use this forward bit as a way to keep track of whether we're in the forward phase or the reverse phase. So that's going to be a condition for the next actuator. So the next rung is going to look like this. We're going to have if forward is true. So I'm just going to grab forward from here. And the A1 actuator is true. Oops, I went past it right here. Then we're going to latch on the B actuator. So we've got another latch output. That's B plus. Okay, and A is going to stay latched on because we want that to stay. It's going to be like the previous sequence. A is going to extend, the B is going to rotate, then C is going to extend, then C is going to retract, B is going to rotate back, A will retract. Okay, so that's all good. So now we have something a little different. We've been using the extend sensors to trigger the next actuator in the sequence. But B doesn't have any sensors. So instead of using sensors, we're going to have to use a timer. When we tell B to actuate, when B plus latches true, we're going to start a timer and just set it for enough time to allow the the rotary actuator to fully rotate. Then when the timer's done, the done bit of the timer is going to trigger cylinder C to extend by powering C+. So we're going to need a timer. So if we go to ladder for Allen Bradley PLC and click on ladder for Allen Bradley 500 PLC, it actually gives us the on delay timer, which is the most common one to use. There are other timers. If you drill down into the menu and go to timer counter, there's a whole bunch of various timers and counters, but right there at the top level they give you this on delay timer. So we're going to drag the timer into the ladder diagram, and now we have to give it an address. So up here there's a little question mark. It's a little help, and if you click it, it shows you the format of a timer address. It's pretty simple. T4, 4 is the number of the timer's register or file number, and we just do T4 colon 0 through 255. So we're just going to use the first number for the address, T4 colon 0, and I'm going to call it B extend timer. That's just a name so we can see what we're using it for. Now to connect it up, it's a little bit, we have to put it in parallel with this latch for B+, because it's going to start timing at the same time as that gets energized. So remember, with Automation Studio you have to connect here. You can't connect out to here. I don't know why it's so picky about that, but it just is. And then this one, I'm just going to run a little connection up like this. Okay, so now we want to figure out a timing that will work. I'm going to just put 2 seconds in here. I may have to change it later on. So the preset is the amount of time that the timer is going to wait until the done bit goes true. So we've got a 2 there. Oh, save changes, yes. Okay. Now the next rung is going to use the forward bit, because that's the condition for all the forward movement, in series with the timer's done bit and get in place of the extend sensor, because there is no extend sensor. So we've got the first input is going to be forward, which we can just get from here, and the next condition. Now that, so since we've created this timer 0, if we look down here under our available addresses, we've got the 3 bits for the timer. The done bit is the one that is going to go true when the timing is done. And then we have these other enable and timer timing, which we don't need. So we're just going to double click that. And okay, and now what's going to happen when those 2 are true is now we're going to latch on. So we have to go back to the bit menu to get the output latch. And this is going to be when we're going to extend C with the C+ output. Okay, I'm going to connect that up. Now this would actually be a good time to test it, make sure it works. In fact, I think I'm going to save this before I do anything. So if we run the simulation, we should see the 3 actuators go to the forward position. They're not going to go back, obviously, because we haven't created the reverse sequence yet. But let's do that. So we go to simulation, normal simulation, and notice how the rotary actuator goes back to this one. It's like a 0 degree position, because it's the air is going in that side of the actuator. So if we press the start button, now rotary actuator actuates. Now it looks like I didn't give it quite enough time, so maybe I need 3 seconds instead of 2. But it's also going to be influenced by the setting on your flow restrictors. So yeah, mine is kind of whatever. I'll just leave it there, and I'll just make this a 3-second timing. I'm going to make one other quick change. I just realized, because I have the flow restrictor connected directly to the pin without a line, it doesn't show you know how it shows red for high pressure and blue for low? I like seeing that, so I need a little bit of a line connection, so I'm just moving it over for that. All right, let's try 3 seconds and see if that works. So if you double click the timer, you go to preset, you can change the timer preset, and let's do it one more time. Yeah, see, now you can see the high pressure pushing the rotary actuator back. So we'll hit start, and A extends, B rotates, C extends. Great. So now we just have to create the reverse part of the sequence. Now I think I'm going to run out of screen room with my ladder diagram, but anyway, I'll just move it up a bit. And I'm going to need a couple more rungs, but now with the ladder, remember you have to hit this insert rung, and then you can click wherever you want. So I got a couple more rungs in there. Okay, so now for the reverse part, what we're going to do, I could hit escape here, okay, is when the C1, the extend sensor, gets triggered, that's going to now unlatch the forward bit. It's going to latch the reverse bit, and it's going to make C retract. So that rung is actually going to be the same as it was before. So the condition on this is just C1. We don't really need the forward bit because C1 is only going to, there's only one time where it will be triggered. So we get that, and we're going to do 3 things. We're going to unlatch the C plus, and that will release the solenoid. It'll spring back. So let me just connect that much up. And then we're going to unlatch the forward bit and latch the reverse bit. So we've got another unlatch, forward, and we're going to latch reverse. Okay, I need some more rungs, so I gotta insert a bunch of rungs. I'll just put a whole bunch in here. And then remember to hit escape to get out of this mode. So now we're gonna, when C retracts, it's gonna hit the C0 sensor. And so we need the 2 conditions. One is the reverse. If reverse is true, and the C0 sensor goes true, that means it's retracted. Then we're going to unlatch the B actuator, which is going to release that valve. It'll spring back, and then the rotary actuator will go back. So unlatch B plus. And just like before, because B doesn't have a sensor to sense that it retracts, we're going to use a timer again. And we need another timer. And so we go up to, where is that now? Okay, on delay timer. Plop it in here. Now we have to use a different address, so this is going to be T4:1. Connect this up in parallel with, now I didn't bother giving this one a name. What the heck, maybe I'll name it, give it an alias of B retract timer. And we'll also make that 3 seconds for the preset. Okay, now same as before, we're going to use the conditions for reverse are going to be if the reverse bit is true, and the timer, the retract timer is finished timing, so that means its done bit goes true. So notice now down here, because I created that new address T4:1, I've got the done bit of the retract timer. And those are going to trigger, okay, that's going to trigger A to unlatch. So we go to the bit address and unlatch A plus, which is right here. And the last thing we need to do is when the retract sensor goes true, that means it's fully retracted, we're going to unlatch the reverse bit. So let's just do that. All right, that should do the trick, and we can almost see the whole ladder diagram. Maybe I'll just zoom out a little bit. Okay, so now let's give it a shot, see if it works. Simulation. Okay, I'm getting an error. Let's see what that's all about. Ah, I made the same mistake as before. So let's fix that. Remember, I have to connect this in parallel like that. I'm so used to RS Logic's 500, which, it doesn't matter where you connect to that other rail. All right, start again. Simulation, normal simulation, no errors, that's good. We'll click start. A extends, B extends, C extends, retracts, B retracts, and A retracts. All good. All right, so those are the first two circuits for Virtual Lab 5. This third one is a sequence that's a little different, where you have to mix some things around. It's got a little different sequence and timing, and that's for you to figure out. It's going to use the same exact hardware, but the program is going to be different. So I'm going to stop the simulation and save before I do anything else.